Hello, Brian Miller-Hicks here. We're talking about engineering geology, and we're going to be talking about engineering geology investigation reports. A report is a very critical work product that the engineering geologist has to produce in cooperation with engineers, geotechnical engineers, and other professionals to submit to a client that describes what needs to be done to handle the geologic issues of a particular property. So it has to show some understanding of some of the major issues that a project may encounter, be it soft soils or too much rock or earthquake faults, etc. The first step in preparing an investigation report is to tell the client how you're going to approach the investigation. That you do with a proposal. So the proposal is an outline of what the investigation is going to be. You have to show an understanding of the project, what the client proposes to construct on the property. You have to know what the scope of your work is going to be, whether it's going to be just 1 or 2 borings or 15 borings or additional exploration work that's going to take a long time and it's going to cost more money. You might also address any need for geologic observations during actual construction or earthwork of the project. That can be critical. So scope of work. Timeline, of course, every client is interested in how long a task is going to take. Is it going to take 2 weeks to do the investigation and the report, which is pretty rare? Or is it going to take 6 weeks? Or is it going to take 2 months? Give them an idea of what the timeline is going to be for you to complete your investigation and complete your report. The cost, of course, obviously is a critical factor in any investigation. And it's important at this point to emphasize to the client, well, this investigation seems awful expensive, but remind him, hey, you've got a $5 million project and we're going to only charge you $10,000. That's a small percentage of the cost of the project. And if we don't do our investigation properly for the scope of work and amount of money that we're going to spend on the investigation, you may end up paying more on the back end to correct issues that haven't been addressed during the investigation. So geotechnical investigations are critical and can often save money in the long run for the project. You want to have an understanding within the proposal of what the major and general geologic issues are: faulting, landslide, wet ground, liquefiable ground, etc. You want to let them know what type of exploration equipment is going to be used. Maybe it's going to be a backhoe, maybe it's going to be a drill rig. Maybe you can't use a backhoe because of limited access, or you have to go deeper than a backhoe will go. Maybe you cannot use a truck-mounted drill rig because of access issues. So point that out, indicate that, put it in your proposal. You have to have a sampling plan for extracting samples and types of samples. Maybe you want to do California split spoon samples or standard penetration test samples, or maybe you want to do cone penetrometer type sampling, or maybe hand sampling from a backhoe. What sort of sampling plan you're going to have, and what kind of lab tests are you going to perform on these extracted samples. Put that into your proposal. Excuse me. Then discuss the framework of the report. What's going to be in the report. You don't have to obviously specifically address issues within the proposal. That comes later after you've done your investigation and have a full understanding of the issues that are out there after you've completed the exploration work and the investigation work. And then, critically important, of course, you want to have a contract or employment agreement which is signed by the client. You want to have that signature and approval before you start any work on the investigation. I have heard of people going ahead with investigations without signatures, and that's a dangerous place to be in. So, okay, you submitted your proposal to the client, and you have to and you've made him or her aware of that you have an understanding of the project, which is going to guide your investigation work. Where is the project located? What are the structures proposed? Include a full description in your proposal. Is it a skyscraper? Is it a bridge? Is it a roadway? Is it single family homes? Type and size of structures, locations of the structures relative to the property. What are the finished floor elevations going to be? Suppose you have a hilly site and you're given, and you know what the finished floor elevations are going to be. Well, that means the site's either going to be cut down to that elevation or filled up to that elevation. And that requires obviously different types of earthwork and different types of exploration. You have when you're doing the proposal and investigation, having a grading plan is very, very important and very useful. Sometimes you don't have that grading plan, but the grading plan will show you where the cuts are going to be, where the fills are going to be. Are you going to need to import suitable soils, or is it going to be a balanced site? In other words, the amount of cut soil that's going to be performed during the investigation balances out the amount of fill soil that's going to be placed to build up certain areas of topography. Okay. So here's a very simple plan that's a project site plan that you have that gives you an understanding of the project. 3 buildings are proposed. 3 buildings are proposed here. Building A, Building B, Building C. Maybe they're at different elevations. You have parking areas. You have landscaped areas. Each one of these areas is going to require different treatment of the soil, which is going to, so each area is going to be graded differently. Maybe this part of the site is lower, so this needs to be built up with fill to the finished floor elevation for building A. Maybe this building is on a higher elevation, and so the ground needs to be cut down. So in the paving area, that has to be treated differently from the buildings, because the buildings, of course, will require foundations. Maybe they'll require deep foundations, so you have to drill down to a certain depth to get samples and to judge the condition of subsurface soils and bedrock. Pavement may be on elevations that are close to natural ground, so maybe you don't have to go quite as deep in these areas and sample quite as deep with your exploration equipment. And of course, pavements don't require deep foundations or anything like that. They're generally built on top of a compacted, tight soil or rock subgrade. So as you can see, different areas of the project are going to be treated differently in your proposal, are going to be investigated differently during your investigation, maybe by different types of equipment. Here is a grading plan for a building that's going to be built here. It so happens that this entire building site is going to be in cut, which means that the finished floor elevation and the elevations in this, I think, parking area are going to be lower than the topography that exists out there now. So this is all needs to be cut down. So when you're doing the investigation with your exploration equipment, you want to make sure you drill down to the elevation that's going to be at the finish grade and deeper. Go deeper than the pavement elevation, because you also have to judge soil conditions for utilities which might be installed at a deeper depth than the parking lot grade itself, for example. And you want to do some special exploration up here where these new retaining walls are going to be built, because you're going to have to make recommendations for drainage and foundations for these retaining walls. Okay. And since this is an all cut site, all the material is going to be cut away to make a flat pad for these structures. That soil has to go somewhere, so it's going to have to be exported out away from the site. You might be able to help the client in helping him choose how to dispose of the excess material and where to ship it to. The contractor might have a good idea for what to do with it. Scope. So the scope of engineering geology work for any project includes some of the following and maybe more. If you have a project site at a certain location, there may be older reports for projects that have been done on this property already or on properties adjacent to this subject property. You want to review those documents. You want to have, again, an idea of the primary geologic issues which will affect development of the site, including, are there expansive clay soils? Are there nearby earthquake faults or earthquake faults underneath the site? You want to get an idea of that. You want to include a description of the exploratory borings within the scope of the engineering geology work, trenches, the geophysical surveys. Include data on laboratory testing of the materials. And in your report, you want to be able to review the data and engineering recommendations for site-specific recommendations, including grading, foundations, retaining walls, drainage, how to handle stormwater. So your report is going to summarize, findings, recommendations, and conclusions. And the report itself must be in California, signed and stamped by a professional geologist and certified engineering geologist and a professional engineer. The body of the report, or the findings that are contained in the report, comprise the body of the report. Within that body of the report, you're going to have a description of regional geology, so that you have a geologic setting for the properties, shows that you understand the geologic setting. What are the geologic formations underlying the property? Is it Friars Formation? Is it Ardith Shale? Is it very old peralic sediments? Is it granitic rock? What's the stratigraphy in general? Then you can go into detail in the body of the report on site-specific geology, including how deep the groundwater is and whether it's going to be an issue or a problem. Body of the report is going to discuss relevant geologic hazards, faulting and seismicity, presence of liquefiable sediments at certain depths, the vulnerability of your project to tsunami. Is it near the coast? There are maps available by California Geological Survey that show tsunami hazard zones, for example. On a hilly site, are you going to be worried about landslides, or a mountainous site? If you're next to a river, will flooding be an issue? If you're on top of plastic, stiff, deep clays, is expansion of those clays when they're wetted, is that going to be a problem? Or perhaps you're located on top of wind-blown sediments that are very porous, and if water is introduced, maybe those soils will collapse. Those wind-blown sediments are called loess, L-O-E-S-S, and it's it's not a common soil everywhere, but it can be found in certain places, and it can be prone or vulnerable to collapse upon introduction of water from development, from irrigation, from water mains, etc. So that's another issue. Conclusions in your report. Is this site suitable for the type of construction that the client wants to construct? General relevant issues again. You want to include a statement in your report that says, yeah, this is suitable for construction. If it's not, then you got to say that too. Or you can say, this is suitable for construction if you follow our recommendations, which most geotechnical and engineering geology reports actually say that. You want to have seismic design parameters regarding or relevant to the building code and American Society of Civil Engineers. And here's a website that can link you to seismic design parameters. So I've talked about findings and conclusions, and here are some recommendations for site preparation. What do you have to do to prepare the site for construction? This stuff should be in your report. What kind of site clearing do you need to do? Do you have to remove vegetation, trees, bushes, all sorts of vegetation, forests? Do you have debris that's been dumped on your site? Do you have old structures like old septic tanks or old homes or old buildings that need to be removed? You have to address excavation characteristics. If you're on a bedrock site, can that bedrock be removed or cut down by ripping into it with heavy equipment, or are you going to have to blast? Is it too hard to be ripped by dozers? And you have to say something about the suitability of the subsurface materials for on-site use, which means typically if you want to use on-site materials, soils for fill, then those fill materials have to be suitable. They can't have too much clay or some other characteristic which is not appropriate. As the site is being graded, you want to give them an idea of what kind of over-excavation is going to be required to remove undesirable soils, old artificial fill materials, oversized rock. What are the recommended fill materials which can be used for the site? Any soil or processed rock which is used to build fill pads for structures are subject to compaction requirements per the American Society for Testing and Materials, typically a 90% compaction with optimum moisture. Those requirements may differ for pavement, subgrade, or special structures. You want to discuss in your recommendations any improvement of the foundation materials. Do you have to get deep compaction to improve the materials for some types of foundations? You're going to discuss the foundation design. If you're in a hilly site, you're going to address slope design and also design of cut slopes and fill slopes, whether they can be 2-to-1 or 1.5-to-1 or what have you. And it's also important to mention parameters of drainage design. You may have some special construction conditions. You might have to include setbacks from active faults, building setbacks. You may have to talk about flood zone setbacks and site drainage. In your report, you want to include structural recommendations for the actual buildings, construction, foundation types, soil bearing pressures, footing dimensions, any setbacks from slopes. Typically, you don't want to have a foundation right at the edge of a slope. You want to set that back away from the slope. You want to give recommendations for slabs on grade, concrete, steel, moisture barriers, etc. Want to discuss soil corrosivity. Maybe your site has soils which contain a lot of sulfates and chlorides. You want to give some recommendations for retaining wall design for the footings, for the heights of walls, for the distance of walls from property lines and so forth, different recommendations. You want to discuss and give recommendations for streets, driveways, and sidewalks, and the preparation of subgrade for those pavements. And importantly, a lot of sites will require stormwater retention basins, so that's something else you can give recommendations for. Finally, every report should have appendices and attachments that include the site map, showing where the buildings, streets, etc. are, including grading plan, if available, the site plan, site location, that means where are you geographically. The site plan itself shows the building layouts. A geologic map, obviously, that's very important. A fault map showing any nearby faults. The references you used, just like in college, you have to put together a bibliography and a list of references you used, which may include other engineering geology reports. You want to put in your trench logs and boring logs that show graphically and verbally what was encountered in those subsurface explorations, layer by layer by layer. You want to include your lab tests and explain what they mean, seismicity if required, and then general earthwork and grading specifications. These are usually standard sections which are included within almost just about every engineering geology report that are standards that are up to the standard of care as to recommendations for slopes, site prep, etc. Okay, so it gives you a better idea of what comprises an engineering geology proposal and report. I thank you